Welcome to Pragim Technologies. I am Venkat. This is part 62 of C# video series. In this session, we'll discuss about the rules to follow when creating partial classes. Before continuing with the session, I strongly recommend to watch part 61 of this video series, where we have discussed the basics of partial classes in C#. We know that a partial class is a class that is spread across two or more physical files using the partial keyword. Now when we have these partial definitions of classes, we need to have the partial keyword on each of the definition of that partial class. Otherwise, we end up getting a compiler error. Let's look at that in action. Let's flip to Visual Studio. I have a simple ASP.NET Web Application project here. Let's add a class file. Right click on the project, click add new item, and I want to add a class file. Let's call this sample partial class 1. Okay, so that's the name of the file. Let's go ahead and add this file, and let's call the class as sample partial class. So this is a partial class. And let's add another class file. Right click on the project, add new item, and I'm going to call this sample partial class 2.cs. Click add. That should add another file, and let's call this. Look at that. This is a partial class, and the name of the class is sample partial class, and this class is present in sample partial class 1.cs file, and we have the same class here. Now I have to use this partial keyword on both the parts of the class. Okay, so on both the parts we are using the partial keyword. So now if I build this project, it should build successfully without any errors. But on the other hand, if I remove the partial keyword here, look at this. For this class, in one of the physical files you don't have the partial keyword, but in the other physical file you have the partial keyword. Okay, now let's try to compile and see what's going to happen. It will give a compiler error saying that missing partial modifier on the declaration of type sample partial class. Another partial declaration of this type exists, and that makes sense because we have a class, sample partial class, which is a partial class. But then in the other physical file you're saying this is not a partial class by not using partial keyword. So it's not possible to create a class like this. That's why we get a compiler error stating so. So keep in mind, all the parts spread across different physical files must use the partial keyword when you're creating a partial class. All the paths spread across different files must also have the same access modifiers, and this is also very important to keep in mind. If we understand the basics of classes, understanding creating partial classes is pretty straightforward. Now we know that a class can have access modifiers. Classes can only have two types of access modifiers, internal and public. Private, protected, and protected internal cannot be used on a class. So if you are using an access modifier, here we are using, let's put the partial keyword here so that we don't get the compiler error anymore. Now if you look at this, on sample partial class 1.cs file, the access modifier is public. Now let's change the access modifier in sample partial class 2.cs to maybe internal. Okay, now look at this. You have a class called sample partial class. It's a partial class. And here you are saying the access modifier is internal, and in this physical file you are saying it is public. Okay, so now which access modifier should the compiler use? It doesn't really make sense, right? So that's why we get a compiler error when we try to build this project. So it throws an error saying that partial declarations of the sample partial class have conflicting access modifiers. At one place you're saying public, in the other file you're saying internal, so it's conflicting with each other. That's why you have to use the same access modifier, either public or internal, on both the physical files. Okay, now if we build this, Ctrl+Shift+B, on the status bar you can see build succeeded. So all the paths spread across different physical files must have the same access modifiers. If any of the paths are declared abstract, then the entire type is considered abstract. Okay, that also makes sense. Now for example, let's say I'm saying okay, this in this sample partial class 1.cs, on this physical file I'm saying okay, this is an abstract class. Okay, but okay, we have to specify partial just before the class. Okay, so this is an abstract. You're specifying, okay, sample partial class is an abstract partial class. Now, I haven't specified abstract class here, abstract keyword on sample partial class 2.cs physical file, but still this class will be treated as an abstract class. If you try to create an instance of this class, you will get a compiler error. Now, look at this. If any of the parts are declared abstract, then the type is considered abstract. Okay, so since we have specified abstract in sample partial class 1.cs physical file, this class is going to be an abstract class. So if we try to create an instance of that sample partial class, we will get an error. Let's say obj. Look at that. I will not be able to do that. Let's see what happens if we try to create an instance of that. Let me build the solution. Look at that. Cannot create an instance of the abstract class. But on the other hand, if I comment that and build the solution, build succeeded. Okay, so if any of the parts are declared abstract, then the entire type is considered abstract. If any of the parts are declared sealed, then the entire type is considered sealed. Again, if you just specify, okay, my class is going to be sealed class, then it's enough if you just specify it on one of the class partial classes, then the entire type will become a sealed class, meaning this class cannot act as a base class for any other class. Okay, so if I build it now, Control Shift B to build the project, build succeeded. Now if I try to use this as a base class for some other class, let's say I'm creating a class here, let's call it public class. Let's call the class as sample, and if I try to use the sample partial class as the base class for this class, remember that we have marked the sample partial class as a sealed class, meaning you cannot use that as a base class for any other class. Now if I try to build a project, look at that, what's going to happen. Let's build this, right click and build. We will get a compiler error saying that cannot derive from sealed type sample partial class. So if any of the parts are declared sealed, then the entire type is considered sealed. If any of the parts inherit a class, then the entire type inherits that class. For example, let's say I have the sample class, for example, and then this has got a sample method. Let's say public void maybe get data method. So that's present in the sample class. And let's say we have the sample partial class, and the sample partial class is inheriting from that sample class. Okay, now if I go to the web form, look at that. Since this partial class that is present in sample partial class 1.cs physical file is inheriting from sample class, this class will also automatically inherit from that. Okay, because essentially at the end of the day, at the compile time, both of these classes will be merged together and they're going to form one class. So obviously when I try to create an instance of this partial class, and then when I say obj dot, I will get access to that get data method, which means both of the parts will have access to that method. In the sense here, I can in this sample partial class 2.cs file, I can still be able to access that sample class method if I want to. Okay, C# does not support multiple class inheritance. We know that a class in C# cannot have more than one base class at the same time. If you try to do that, we get a compiler error. So when it comes to partial classes, different parts of the partial class must not specify different base classes. Okay, so which means, okay, this is sample partial class 1.cs file. Here I am saying, okay, the base class for my partial class is sample. But here in this file we haven't specified any base class. So if I try to build this project, it should build without any errors, build succeeded on the status bar. Now let's say let's create another class here. Let's call this public class employee. So we have an employee class here, and let's say for this partial definition of the class, I'm saying it's inheriting from the employee class. Now if you look at this version of the partial class is inheriting from employee, and this part of the partial class is inheriting from sample. So effectively you're saying your partial class is going to inherit from two classes at the same time. So obviously when I try to build this, we get a compiler error saying we cannot do that. Partial declarations of sample partial class must not specify different base classes, and that makes sense because C# doesn't support multiple class inheritance. Okay, so let's get rid of that. And now if I build the solution, build succeeded on the status bar. Different parts of the partial class can specify different base interfaces, and the final type implements all of the interfaces listed by all of the partial declarations. And that also makes sense. For example, let's say I have this partial class. Let's actually create two interfaces first so that we can inherit from them. Let's call this iEmployee, for example, and let's call this iCustomer interface. And let's say this interface is having a method called void employee method, and let's say iCustomer interface is having a method called customer method. Okay, now we have two physical files which has got the sample partial class. Let's say this sample partial class is in implementing iEmployee interface, and this sample partial class is implementing iCustomer interface. And if you remember, if a class inherits from an interface, then the class has to provide implementation for all the interface members. Now keeping in mind this is a partial class, look at that. One part of the partial class is implementing iEmployee interface, and the other part of the sample partial class is implementing iCustomer interface. Now the net effect is the sample partial class has to implement both the interface members, meaning they have to implement employee method as well as customer method. Now let's say this part of the sample partial class is implementing iEmployee interface. Let's say void, that's employee method. Okay, right, so it has implemented that method. Now let me build this project. As you might expect, we will get a compiler error now. Okay, why? Because the sample partial class is implementing two interfaces. One is iEmployee and the other one is iCustomer. But if you look at this, we only have implemented iEmployee interface method. We haven't implemented iCustomer method. That's why we get an error. Partial declaration of sample partial class must not specify different base classes. We are getting an error. Okay, these are interfaces, so let's call them interface instead of class. We should have done that first. Okay, now let's build a solution. Okay, that makes sense now. Look at that. ADODemo.samplePartial class does not implement interface member iCustomer.customer method. We have already implemented the employee method, but the sample partial class, which is inheriting from iCustomer, hasn't provided the implementation for the customer method that's present within this interface. Now we can implement that method either in this sample class, in this part of the partial class, or you can do it here if you want to. Okay, let's do it here for example and see if it works. So public void, and if you remember, the name of the method is customer method, so let's copy that and paste it here. Okay, now let's compile the solution and see if it works. Build, look at that, build succeeded. Though they're spread across two physical files, here this part of the sample partial class is implementing is inheriting from iCustomer interface, but then we provided the implementation for this interface method in the other physical file where we have the same partial class, but still it works. Now I can take this, if I want, I can take this employee method from here. Look at that. This sample partial class is implementing iEmployee interface. But then in this version of the class, I don't have the iEmployee interface method implemented. I'm going to implement that here, but still it will work without any problem, because the net effect here is the sample partial class is in implementing iCustomer and iEmployee interfaces. And if you look at both of these two physical files, they are providing the implementation for both the interface members. That's why we don't get a compiler error. It really doesn't care whether you have provided implementation in this file or in this file. At compile time, it's going to combine both of these classes. It checks, okay, this sample partial class is implementing iCustomer and iEmployee interfaces. So is it providing implementation for all the interface members? If the answer to that question is yes, the class will be successfully compiled without any issues. And that's what is happening at the moment. So different parts of the partial class can specify different base interfaces, and the final type implements all of the interfaces listed by all of the partial declarations. Any members that are declared in a partial definition are available to all of the other parts of the partial class, and that makes sense. For example, here, this partial class is spread across two physical files. Let's say I have in this partial class maybe public void, let's call this method 1 maybe, and let's copy the same thing and put that in the other physical file. And I have another method here, and let's call this method 2. So which means now this is single partial class. At compile time, we know that these partial classes will be merged into one class. So obviously when I try to create an instance of this class, and then I will be able to access method 1, method 2, employee method, customer method, all these methods. Not only that, this version of the partial class, it can access the members that we have defined here, and whereas this partial class can access members that are defined within this class. Okay, so each partial classes can access members defined in the other parts. So any members that are declared in a partial definition are available to all of the other parts of the partial class. On this slide, you can find resources for ASP.NET, C# and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.